What's going on, guys? Welcome back to another CNC video. Today we are checking out this big old thing. This is my huge, like 4-foot CNC that I built. We're gonna go through it, show you how it works, how you can make your own, and yeah, let's get into it. You guys are crazy. The last couple of videos we've gotten like 8,000 views in what, 5 days and 60 subscribers, so keep it up. We're getting to 1,000. We can keep making more videos with all these subscribers. So yeah, appreciate it. So subscribe and let's get into it. So this is my large CNC that I made myself. We're just gonna kind of give you a quick overview and what the plan is for this. So here's my dog. He wanted to say hi. Anyways, back to the CNC. This was all done by hand. No parts on this were CNC'd. I did have a 3D printer, so I 3D printed all of these cable chains, which are actually very handy. I would highly recommend doing that if you have a 3D printer. As I also 3D printed spacers here for these motor mounts, as well as these ones. Very handy, and a lot of covers for the electronics. So let's just get down to business here. This is approximately 4 foot by 4 foot and about 3 feet of working area. So actual milling size is about 3 feet by 3 feet. I'm just running a cheap Chinese spindle. I was running a 500 watt and then I broke it, being dumb. So I upgraded to a 700 watt spindle. And this one goes 17,000 RPMs. So far, it's pretty good. Haven't really had any issues with it. This is a ER20, call it, I believe. Or maybe it's 18, I'm not 100% sure. But it's slightly larger than the ER11, which I had, which is very nice. So I can run a bigger tool. So this is it's kind of in the way. This is my gantry plate here, my Z-axis. It's mounted onto 2 linear rails, HGR 20 or HGH 20 maybe. Whatever, it's 20 millimeters wide is essentially what that means. And this thing cannot just like relax. There you go. And then it's also running on a ball screw in the back here, as you can see. So that's what makes it go up and down. I'm also running NEMA 23 steppers from Stepper Online. They have been great motors so far. They're relatively well priced. They're not going to break your bank. This gold tape that you see on them, well, copper tape, this is grounding the motor to the whole machine so we don't have any ground loops, which supposedly is an issue with steppers and CNCs. So this is one way that we could get around that. So that's how we did that. And I just have this taped up here so that way it's not disconnecting my spindle in the middle of it. It's just an air-cooled spindle, just for your information. Yeah, that's pretty much it for the Z axis. Oh, this is all, I believe, Cat. What is it? Cat 5 wire, maybe? Some sort of Ethernet cable, I believe. It's shielded, so we don't have any issues with noise. It's been wonderful so far. Now, if we go down to the large X, let's go to the Y axis. Our gantry. So, moving side to side, we have 2 plates of aluminum that we welded together right here. And then on the back, that attaches to these 4 of these. You can see the rails, 1 rail here, 1 rail here. So we got 2 blocks, carriage blocks on each rail. It's very sturdy, doesn't move anywhere. Also running off of a huge ball screw that we bought off eBay. I think they're like maybe $100 a piece, so they're not terribly expensive. We didn't buy like any name brand, just, you know, Chinese version. Been working great so far. No issues. Definitely better than a lead screw. And then this is Stepper Online's larger NEMA 23. I think this is their largest. I'll make sure and link all of the motors down in the description. And then I 3D printed a spacer. Oh, one thing to mention, the couplers on these. So this is just your, oh, come on, focus. This coupler right here, this is just your standard like 3D printers. I think they're spring couplers. And then you can't see it in here, but this coupler we had to replace because we actually broke that coupler. So in here we have, I believe, a diaphragm coupler. So much more substantial than like this. I'm out of breath, oh my goodness. This coupler, or these types of couplers here, they are not as rigid, whereas the coupler in here, I can't really show it, but it is a lot more rigid and just how it's built. It's very interesting. I would highly recommend looking into them for your drive system. And then the actual main gantry. So it's just, oh, this is also a 1/2 inch 6061 aluminum that's been welded together. So we just had a weld. Well, we have a plate here that sits on two of these. Oh, I can show a better angle over here. I'm gonna say, I think it's HGH20 linear rails. Also, just cheap eBay ones that we bought on eBay. Nothing special. They're working great. So yeah, we have one piece of aluminum going from all the way out here, all the way across. And then we have this piece of aluminum that is welded in down here. My dog is getting in the way again. Hello, Milo. Excuse me, sir. Sorry. So this is the plate that mounts to the carriage box. Sorry, I'm stumbling with my words. And then we have another side mount bracket, or a plate welded to the side here. And then inside of there is our ball screw mount. So that mounts to another large ball screw that goes the whole length here. And that connects to a small NEMA 23. These are the same size on the Z-axis. The only larger one is the one on the Y-axis here. So that's how the whole X-axis works. We got one motor on each side, so one motor there, one motor there. They do great. One thing to mention, I'm not 100% sure that everything is lined up properly since I had to do it all by hands. So when the whole gantry, you know, it's coming back, when it gets to about here, you can see this little dust mark. Something's not happy in the motor and the coupler, and basically it starts skipping steps, I think, which throws the alignment out of this. So we end up with diagonal lines. Instead of going like this, you know, it now looks like that. That's not good. So, something to note, be very careful in your alignment. It's very critical. It's really hard to do when you don't have a CNC, but it's just what we had to do. And then on the back of the gantry here, we have, oh, I guess I forgot to mention this, sorry. So these rails are mounted with T-screws or T-slot screws into this 2040 extrusion, which the 2040 extrusion is just directly tapped into this 1/2 inch aluminum plate. And same thing on this side, we put 3 things of aluminum extrusion just to kind of give it some more rigidity. It's still a very strong gantry. To my knowledge, we don't have any issues with deflection. So that is great. And yeah, that's pretty much all the mechanical stuff. So now we're gonna get into the electronics. All of this fun stuff. It's really simple. I actually recently just upgraded. So originally, instead of this board right here, this is a Linux CNC, or this is a Mesa board. I'm not sure the exact number, but it's running Linux CNC on it. I recently upgraded to this board from an Arduino Uno, which is running Gerbil. This was a great software. It was very cheap. It was $8 for the Arduino. It wasn't even like a true Arduino. Let me see if I can find it real quick. All right, I was able to find it. So this is our Arduino Uno that we were running. And then on top of it, this green board. That was just a breakout board that we had. It was very handy for this. I would highly recommend getting a breakout board for the Arduino Uno. It makes it so much easier. But even before that, I was running a CNC shield on it. And these are the drivers that come with it. I would not recommend this, and it's not near as user-friendly, and it's very easy to burn up a stepper driver. Also, one thing to note that I did not know, you want to make sure that if you're going to disconnect one of your steppers, so say I wanted to disconnect this stepper motor, right? I pull the plug. You want to make sure and remove that stepper driver too. If you leave a driver in there without a motor, you'll burn up your driver instantly. I did that and got some little magic smoke. So don't do that. Be better than me. So this was what we ended up going with. We did this, and then we have stepper online drivers. We have 4 of them. They're very reasonably priced. I think about $25 a piece, maybe even less. I would recommend buying your motor and driver combo. You save a lot of money there. So if you want to save $1, that's your way. And these are just wired from here into our board. Pretty simple, nothing else. And then coming out, it just goes straight to our motor. So let's see here. I actually have, which one is it? Not sure. I believe this one. It's jumpered from here to here. This is my X-axis. So this motor and this motor, they're jumpered together. So they both are driven off of one port on here. Makes it pretty simple. So one signal controls both of these motors. And then this is just a, I'm not even sure what you call it, a block of some sort. Let me think of the name here. I'm on terminal block. There we go. So this is just all for a bunch of grounds. So everything is grounded through here. Made it pretty easy because I had a lot of grounds. Made it easy to connect everything and disconnect. We come over here. This is our main power in. A nice little switch. Screws don't work. Need to fix that. This is our, I think, a 48 volt power supply. This is what provides voltage to not to our board. We have a separate power supply for our board. Oh my goodness, I am shaky. Sorry, let me try and calm her down. All right, this is our power here. So we have a separate power that we plug into the wall here. I believe it's 5 volts. 48 volts goes from this power supply to our drivers. So we got 48 volt drivers. And then main power, so 120 from your wall, comes in here to these blocks. We have, what is this? I think this is line, neutral, and ground, something like that. Maybe this, yeah, this is ground, yeah. Something like that. Oops, sorry, I wasn't betting on that. This is line, neutral, ground. And then in here, we have, it's screwed down, but we have a noise isolator. So any noise coming in from this huge power supply, hopefully will not affect the rest of the system. So we just put one on our spindle because that was where majority of the noise would come from. We thought, since this is a cheap power supply, this is a 100-volt power supply, and this is just for the spindle. So the spindle is attached here, goes all the way over to the spindle, and then this is how we control our speed. Although, when I redo this, I would like to hook this potentiometer up to the board, and I believe we should be able to control it all through the board. Should make it a lot easier. One of the things with Linux CNC is you do have to have a standalone computer running Linux. So cost of entry using Linux CNC, not the cheapest, but it is very capable. So we just have an old computer set up. I don't have it completely set up right now because I just moved the CNC. But this is what we'd use. Nothing crazy expensive. I don't think it even has a GPU in it. Or maybe it does, but it's an old one. And yeah, that's pretty much everything. So, when it comes to the 5-axis CNC, the goal is to take all these electronics, squish them into a box, and basically, I can take the box from here, all the way over here, and just plug in the 5-axis CNC. And in my board, I'll just switch profiles from this CNC to that CNC, and everything should be good, theoretically. So I'm not gonna have to be rebuying electronics, which will be awesome, save me some money. I know I'm cheating a little bit because that's a lot of money just in electronics, but you gotta do what you gotta do. In theory, I could just run it all off Gerbil, which I might, who knows? But that is definitely an option. This is like, I think just this setup is like maybe 20 bucks, 30 bucks. And then you just get your steppers. You could even run these steppers if you want. Don't recommend, but you run those steppers from here, yeah, no problem. 100 bucks, you're good to go. So yeah, that's pretty much it. Thanks for watching. If you got to the very end, say hi, Milo. Tell him to subscribe. He said to subscribe if you didn't get it. Yeah, have a good one, guys. Thank you for watching. Make sure you subscribe. See ya.